Today we're going to start chapter 2.1. So we're going to talk about units of area and volume. I will be posting a worksheet to review perimeter and circumference that I want you to work on. You can either do this before or after we do the notes. And so remember, so what we're going to do, area and volume, which is the inside part of a shape. So if you have a circle, what's the area of the circle inside? Circumference would be just if you walked along the outside of the circle, how far would you walk? Or same with a perimeter. So a perimeter of a yard would be just if you walked along the outside of the yard, what would you walk? And then area would be how much space is inside. So because perimeter and circumference are something you'll have seen several times before, we're not going to go over it. Of course, next week if you're having problems, you can come and we'll go over it a little bit, but we'll work on the perimeter of circumference, and today we'll talk about area and volume. And when we talk about area and volume, we are talking about 3D objects. Okay, so this isn't just an object that you draw on the board anymore. It would be something like a cube. So drawing it 3D. Okay, something you can hold in your hands and that's tangible. So we're area and volume, and we'll do both SI and imperial units. We will talk about volume of spheres, right cones, right cylinders, right rectangular prisms, and right rectangular pyramids, and we'll talk about what all of those are. And if you look in your data pages, you'll be able to see those there too. And then we'll be looking at cube roots and square roots a little bit, because that's what's involved in doing surface area and volume. And so here you go, your data pages. If you look on page 2, you'll find all the areas, and you're given the formula. So you don't have to memorize all the formulas, you're given them. And then on page 3, you're given the formulas for surface area. And units of area are always squared. So you'll always put a little squared. So it'll be like meters squared, centimeters squared, kilometers squared, miles squared. If it's area, you have to have that little squared up there. So to find the area of a square, so let's draw a square. So if you have your width is 6 centimeters and your length is 6 centimeters. Your area, and you can check out your data pages if you want, or you might remember this from previous math, will be length times width, which is 6 times 6. And so then area equals 36 centimeters. And what do we always put for area? We always put that it's squared. And that's your answer. And for a rectangle, and I'm sorry, my square didn't look very square. I'll try to draw it better. That's a little bit better. Now for my rectangle, if my width is 5 meters and my length is 8 meters, so my length is 8 meters. What is my area? For square or rectangle, the formula for area is length times width. So I have 8 times 5. So my area equals 40. I'm working with meters. So it will be 40 meters squared. Because it's area, I'll always square it. So a square or a rectangle area is length times width. So that's pretty straightforward. It's a little bit more complicated for a circle, but not much. So if you have a circle, half of the circle, so if you draw a line down the center, this is your diameter. Okay? So along that line, the diameter is half the circle. And then if you draw a line from that halfway line to the edge of the circle, that's called your radius. So there's your diameter and your radius. And radius is what we're looking for. because the formula for a circle, for the area of a circle, is pi r squared. Now, you'll use the pi button, and I wrote this down here, on your calculator. Do not use 3.14. Just use pi all the time so we can be as accurate as possible. So we fill out pi, and r will give that it's 3 meters. Okay, so we'll put 3 squared, and if you put this in your calculator, so 3 squared is 9 times pi, works out to 28.3 meters, and we have to put meters squared so that we know its area. So after this point, if you want to practice this right away, you can try section 2.1, or sorry, worksheet 2.1, part 1. We'll practice basic formulas for area, but I'm going to move on so you can stop the video and come back, or just keep watching and do it all at the end. So for volume, if we're working with volume, we want to cube our values. So centimeters cubed, or meters cubed, or kilometers cubed, or feet cubed. Okay, so volume is cubed, area is squared. And again, your data pages will have these formulas on page 3. If we look at the formula for volume, and we'll work with a rectangular prism first. So we'll draw our prism. And it won't be perfect, but you can see that it's 3D. And so we look for, again, we want our length and our width. So here's your length. Your width would be along this part here. There's your width. And then we also need height. Because this is 3D, we'll need to use our height also. So area for a rectangular prism, and again this is in your data pages, is the area of the base times height. So the base of this square, so if this is, say, your textbook, the area of the base would just be the area of, say, the back cover of your textbook multiplied by the height. And so that translates into length times width times height. Okay, so where the area of a rectangle was just length times width, the area of a rectangular prism is length times width times height. So let's work on an example of that. So let's draw our rectangular prism. Okay, we'll just draw this. Just a quick version. So we have dimensions of 1 foot by 3 feet by 5 feet. So this will be, our height will be 1 foot. So here's your height. Your width is 3 feet. So here is 3 feet. And then your length, 5 feet. And because we're multiplying them, it really doesn't matter what order you put them in, because when you multiply them, it will still give you the right answer. So to find our volume, and remember that for our volume, it's going to be equals something cubed. Okay, so in this case, it will be feet cubed. So how do we calculate that? We do volume equals length times width times height. So 5 times 3 times 1, and you get 15 feet cubed. And there you go. That's how we get volume. Okay, so now you'll be able to do part 2 of worksheet 2.1. And again, I'm going to keep going, but you can stop the video or continue till we finish and then go back and do the worksheet. So sometimes we'll have to find area and volume in different units. So we might be given feet but asked to express it in inches or something like that. So let's see what we have to do. And we're going to have to use our conversions here. So determine the area of a rectangle. So let's draw our shape. And this is just a rectangle. So it's not 3D, just nice and simple. That is 1.7 by 2.5 meters. So my width will be 1.7 meters and my length is 2.5 meters. And I'm asked to find the area in centimeters squared. So first we have to convert our width and length from meters into centimeters. So convert length and width into centimeters. So we'll do our length equals, we know 2.5 meters, or sorry, we have 2.5 meters, and we know that there are how many centimeters in a meter? I hope you said 100. So we have 250 centimeters and 2.5 meters. And in width, we have 1.7 meters. We know there are 100 centimeters in a meter. I'll cross those out. So we have 170 centimeters. And now all we do is find our area. So our formula for area for a rectangle is A equals length times width. And we'll get 250 times 170. And so A equals 42,500 centimeters squared. Okay. So let's look at example 2. Determine the area of a rectangle that is 50 millimeters by 25 millimeters in square meters. So remember that meters are way bigger than millimeters, so we'll probably end up with a really small number. So let's see if we do. We draw a rectangle, and it will be 50 millimeters for our length and 25 millimeters for our width. We'll convert. So for length, we have 50 millimeters. We know that in 1 meter there are 1,000 millimeters. So we end up with 0.05 meters, which is pretty small, which is what we thought we would see. For width, we have 25 millimeters. We know that in 1 meter there are 1,000 millimeters, and so we'll have 0.025 meters. So then how do we find area of a rectangle? What's our equation? Area equals length times width equals 0.05 times 0.025. So area will equal 0.00125 meters squared because it's area. So that's 2 examples of how we can convert, and those are from SI to SI. We can also do SI to imperial. So determine the area of a rectangle. So again, we have our rectangle that is 10 centimeters by 100 centimeters. So our width is 10 centimeters and our length is 100 centimeters. But we want to know our area in square feet. So area is how many square feet? We don't know, so let's find out. So first we have to convert length and width into feet. Okay, so length equals, we have 100 centimeters. And we're going to have to do 2 conversions here because we have to go from centimeters to feet. And if you look at your conversion chart, there's not a direct one. So let's go from meters to feet. So in 1 meter, there's 100 centimeters. And then in 1 foot, there are 0.3 0.3048 meters. So then my meters cancel out, my centimeters canceled out, and I'm just left with feet. And that gives me 3.2808 feet. And I'm going to keep a lot of decimals right now because we still have quite a lot of work to do, and I want it to be as accurate as possible. Then we have width, and we have 10 centimeters. Again, we'll go from meters to feet. So in 1 meter, there are 100 centimeters. Now I can cross out my centimeters. And in 1 foot, we can use the same conversion. There's 0.3048 meters. My meters cancel out, my centimeters canceled out. Now I just have feet. So I have 0.328 feet. Okay, so now I've converted, and now the second thing we do is find area. And area of a rectangle equals length times width. 3.2808 times 0.328. Just kind of losing space there. And we end up with area equals 1.076 feet squared, because it's area, so it's always going to be squared. So our last example for this would be a moving truck has a length of 3.5 meters, a width of 2.3 meters, and a height of 2.2 meters. What is the volume of the truck to the nearest cubic foot? So we want volume in cubic feet. Because we have a length, a width, and a height, this is no longer a regular triangle. This will be our rectangular prism. Okay, so there's our thing, and you can pretend that it's on a moving truck. Okay, so we have our height is 2.2 meters. Our length is 3.5 meters. And our width is 2.3 meters. Okay, so volume, our formula will be volume equals length times width times height. But what do we have to do first? Since we're in meters and we want to be in feet, first we have to convert everything, convert into feet. Okay, so length, so we have that it's 3.5 meters. And we know that in 1 foot, there are 0.3048 meters. My meters cancel out, end up with 11.483 feet. For my width, we have that it's 2.3 meters. Again, we know in 1 foot there are 0.3048 meters. So we end up with 7.5459 feet. And then lastly, for height, we're given that height is 2.2 meters, or we have that. Same conversion. In 1 foot, there is 0.3048 meters. So we end up with 7.2178 feet. Okay, then we calculate volume. Volume is length times width times height. And that will be 11.483 times 7.5459. Again, we've kept lots of decimals just to be accurate. 7.2178. And we end up with 625. We're going to round that up. And what's our units for volume? In this case, we're going to be in feet. So feet. And it's going to be cubed, feet cubed for volume. And now on worksheet 2.1b, you can do question 1 to 5. So on Tuesday, if possible, and please email me if it's not possible. Please come at 12 so that we can do 2 in-class lessons next week, just so that we can meet and make sure that you're keeping up and that everything's going all right. Bring any of the worksheets for the keys that I have. So if I haven't posted a key, bring me the worksheet so I can mark it. And depending on how things go, definitely on Thursday, but maybe on Tuesday, I'm going to have you write 1 or 2 small quizzes just so we can start getting some marks generated for you. So please email if you have any questions, and if not, I will see you on Tuesday.